Selecting the right sample size is important in statistics. Sample too few and the margin of error may be unacceptably large. Sample too many and you may spend more money than is needed to find any differences that would be practically important. This video explores these issues and accompanies the discussion of sample size and power in open interest statistics. First, we will review the algebra related to finding a sample size for a certain margin of error. Then we will learn about power and the type 2 error rate. Lastly, we will think about sample size as it relates to statistical significance versus practical significance. Let's start with a healthcare example to learn about the steps connecting sample size and margin of error. Suppose a company wants to estimate the average blood pressure of its employees to help project its future cost obligations. Blood pressure oscillates with the beating of the heart, and the systolic blood pressure is defined as the peak pressure when a person is at rest. The standard deviation of systolic blood pressure in the United States is about 25 millimeters of mercury. How large a sample is necessary to estimate the average systolic blood pressure for a large company with a margin of error of 4 millimeters of mercury at a 95% confidence level? We begin by noting the margin of error at the 95% confidence level is 1.96 times the standard error, which is the population standard deviation divided by the square root of the sample size in this case. But we know some of the values from the problem statement. In particular, the population standard deviation is 25 and we set the desired margin of error equal to 4. Now we can solve the inequality. We want the actual margin of error in practice to be no larger than 4. Rearranging the square root of the sample size and squaring both sides leads to the result that our sample size must be larger than 150.06. However, since we can't sample a fraction of an employee, we should choose a sample size of at least 151 employees. The sample size also impacts the power of our hypothesis test, which is the probability of rejecting the null hypothesis when the null hypothesis is actually false. Suppose we had a large sample. Then even a modest difference between the null claim and the true population parameter would likely be enough to reject the null hypothesis, because the standard error of the sampling distribution would be small. On the other hand, suppose we had a small sample. Then we would need a large difference between the truth and the claim in order to reject the null hypothesis. When the sample size becomes larger, point estimates become more precise and any real differences in the mean and null value become easier to detect. Even a very small difference would likely be detected if we took a large enough sample. While we still say that the difference is statistically significant, it might not be practically significant. This video introduced important ideas that should be considered when choosing a sample size, planning a study, or planning an experiment. If you learned something you found interesting, share this video with a friend and visit openintro.org for more resources.